You're listening to the N2K Space Network.
Hi, I'm Brandon Karpf, Executive Director of N2K Space. I want to share with you a word from our sponsor, the Italian Trade Agency. If you didn't know, Italy plays a critical role in the international space economy as one of the largest and most advanced aerospace manufacturing hubs. From satellite systems that connect the world to interplanetary missions that push the boundaries of exploration, Italy stands at the forefront of space advancement. JUICE, Euclid, Artemis, DART, and Webb, Italy's space industry had a significant part in each of these missions. Italy is now launching a new business acceleration program in the United States completely dedicated to aerospace with 6 groundbreaking new startups right in Houston. Tune in as ITA unveils the unparalleled innovation and excellence that brought Italy to be a top U.S. aerospace supplier. Visit itahouston.com/spaceitup23 to learn more. You can also visit space.n2k.com/ITA for a whole bunch of new information. And a sincere thanks to our friends at ITA for sponsoring this podcast.
To repurpose a meme. When launch Ariane 6? Well, ESA says soon enough, or at least we'll let you know for sure in October.
T-minus 20 seconds to LOS speed rest. Go for deploy. Roger roll.
Today is September 5th, 2023. I'm Maria Varmazes, and this is T-minus. ESA delays decisions on Ariane 6 till October. Vikram and Pragyan say goodnight for now. SpaceX's Crew 6 splashes down in Florida. And our guest is space biologist and UNCG professor, Dr. John Z. Kiss, on why we should be studying plants in space. Stay with us. Let's take a look at today's Intel briefing, shall we? The European Space Agency yesterday released some key milestones for the much-anticipated and sadly much delayed Ariane 6 launcher. Components of the Ariane 6 are currently undergoing various combined engine tests. Recently, ESA and Ariane Group completed an 11-minute upper-stage hot-firing test at DLR's Rocket Engine Test Center in Lampoldshausen in Germany on the 1st of September. And we should know soon the results of the next hot fire test of the main stage, which is happening in Kourou, French Guiana, sometime today. There are at least 2 more tests planned for the later part of the year. There's one coming up in early October and one at an unnamed date that will be later in 2023. Still, after completing that early October engine test, ESA says that they should be in a place to set a first launch date for the Ariane 6. In a press conference, ESA Director General Joseph Achbacher told Reuters that he anticipates that a flight test should be not too late in 2024, though it's unlikely to be in the first half of the year. And 6 months after that test occurs, we should see the first commercial mission on the Ariane 6 underway. In the meantime, we wish Ariane Group and ESA all the best as testing continues. And staying in Europe, and researchers at Bangor University say they've developed an energy source which could allow astronauts to live on the moon for long periods of time. Scientists at the Welsh University have designed nuclear fuel cells which are as small as the size of poppy seeds to produce the energy needed to sustain life there. The Bangor team works with partners such as Rolls-Royce, the UK Space Agency, NASA, and the Los Alamos National Laboratory on fuel research. The team hopes to fully test the nuclear fuel over the next few months. And speaking of the moon, we're saying goodnight to Vikram and Pragyan, at least for now. The Indian Space Research Organization announced on the platform, formerly known as Twitter, that their lunar lander and rover are now in sleep mode. ISRO says that the vehicles have completed their experiments on the lunar surface for now, and will be awakened at the start of the next lunar day, which begins on September 22nd. Mumbai-based startup company Manastu Space has raised $3 million in a pre-seed Series A funding round. The company says it plans to use the capital for the development and deployment of its green propulsion and debris collision avoidance system. The company has already secured several contracts, including one with Indian Defense and a partnership with French startup Latitude. After making a spectacular plasma streak across the Florida skies, SpaceX Crew 6 splashed down over the weekend, returning 4 astronauts from the ISS, including the UAE's Sultan Al Nayati. The Emirati completed 6 months on board the space station, marking the longest mission by an astronaut from the United Arab Emirates and completing the first spacewalk by an Arab astronaut. UAE President Sheikh Mohammed took to the platform, again formerly known as Twitter, to say this: Sultan Al Nayati, the people of the UAE are immensely proud of you and the entire team for achieving major advances in space exploration. You carried the dreams of a nation to new frontiers, and we celebrate your pioneering journey and a safe return. The UAE's investment in the space sector has nearly reached $6 billion. Japan's government has committed 10 billion yen to the country's space agency in fiscal 2024 as a fund for companies and universities engaged in space development. JAXA plans to allocate the funding to entities that develop technologies like satellites, rockets, and advanced technologies for lunar exploration. Japan says the funding will be similar to the grants provided by NASA to U.S.-based companies for the development of space technology. SpaceX successfully launched 13 Space Development Agency satellites over the weekend, and communications have already been established with many of the vehicles. The spacecraft were delivered in orbit for the Tranche 0 transport program, part of the Space Development Agency's proliferated warfighter space architecture. Firefly Aerospace has signed a multi-launch agreement with L3 Technologies for 3 dedicated launches on Firefly's Alpha vehicle in 2026. The companies did not announce the contractual amount for the services. The missions will lift off from Firefly's SLC-2 launch site at Vandenberg Space Force Base. Now, the satellites haven't even launched yet, but the partnerships keep rolling in for Amazon's Project Kuiper. The latest deal announcement comes with Vodafone. The telecommunications company plans to work with Amazon's low Earth orbit constellation to increase the reach of its 4G and 5G networks across Europe and Africa. Vodafone and Amazon plan to roll out Project Kuiper's high-speed broadband services to underserved communities around the world. British company Vodafone is also working with AST Space Mobile to develop a space-based mobile network that would connect directly with standard mobile phones without the need for specialized equipment. Australia-based Fleet Space is partnering with Thor Energy to use space-based technology to develop more precise and efficient mineral drilling campaigns. This collaboration will drive surveys using Exosphere by Fleet technology, initially over the northern part of the Alford East Copper REE project in South Australia. This low-impact exploration technique harnesses natural environmental vibrations to analyze the Earth's composition at significant depths. The partnership will also see Fleet Space Technologies taking an equity stake in Thor Energy, signifying both parties' long-term commitment to the project. That concludes our Intel briefing for today. You'll find further reading on all the stories we've covered in our show notes, and we've included a few extras on China's space exploration. You'll definitely want to check out the video showing the Tiangong space station taking form. And we also have a story linked today on the legality of ESA's lack of transparency. Really interesting. You'll find all those stories and much more at space.n2k.com. Hey T-Minus crew, if you're just joining us, be sure to follow T-Minus Space Daily in your favorite podcast app. And also, if you could do us a favor, share the intel with your friends and coworkers. For example, here's a little challenge for you. By Friday, please show 3 friends or coworkers this podcast. That's because a growing audience is the most important thing for us, and we would love your help as part of the T-Minus crew. If you find T-Minus useful, and we really hope you do, please share it so other professionals just like you can find the show. Thank you so much for your ongoing support, everyone. It means a lot to me and to everyone here at T-Minus. Our guest is Dr. John Z. Kiss, an esteemed space biologist and professor at UNCG who studies plants in space. Our producer, Alice Carruth, started off by asking Dr. Kiss about his recent studies.
Let me tell you about one of our last studies on the International Space Station, and the project was called Seedling Growth. It was a joint project between NASA and the European Space Agency, and I was the NASA principal investigator, project scientist, and I had a colleague in Spain, Javier Medina, who was the principal investigator in Europe. And what we looked at was actually the growth of plants in reduced or fractional gravity. So what we know a lot about is we know a lot about plants in microgravity, like in orbiting spacecraft. We know very little about plants in fractional gravity. And what do I mean by this? Well, if we look at the moon, the gravity level relative to Earth is 1/6. So if we say Earth is 1g, the moon is 1/6g, 1/6, and the gravity level on Mars is higher. It's 3/8 g. And we have opportunities on the International Space Station to study this. As we could do experiments in microgravity, and we used a centrifuge to create gravity, and we replicated the Moon-Mars levels. We found a lot of interesting things, but I think one of the most interesting things, at least for the parameters that we studied, the Mars gravity level was pretty much the same as the Earth gravity level. So the plants pretty much behaved in terms of gravity the same on Mars and Earth. Moon is another story. Moon was much more like microgravity. So the practical implications of that is, in terms of gravity, greenhouses on the moon are going to probably have to be different than greenhouses on Mars. And in some ways, it's easier to have the greenhouses on Mars because in terms of gravity, they're very much like Earth. And that's a really cool finding.
It's a really cool finding, particularly if you're a big fan of the book The Martian, where they obviously did study the idea of growing potatoes on Mars. And what other studies have you done with looking at plants in space? Because I know there's quite a few others that you've been co-principal on as well.
Well, one of the interesting things, if you look at environmental signals that plants respond to, and plants are very sensitive to their environment. They can't run away like animals, but they're very sensitive to their environment. The two most important signals in terms of plant development are gravity and light. And we kind of know this. So if you look at a germinating seedling, the roots very quickly want to go down and the stems want to grow up. And that's because of gravity. Plants are also very responsive to light. If you look at your house plants, if you put them on a windowsill, usually you have to rotate them because they're bending toward light. That's called phototropism. The roots bending down and the shoots bending up is gravitropism. So directed response to gravity, gravitropism, directed response to light, phototropism. And I'm very much interested in the interaction between the two. And one of the things we could do in microgravity is you could take away the gravity signal and study a pure light effect. You could make an extreme statement that you really can't study light effects on Earth because gravity, as soon as a plant starts bending, gravity also has a role in that. So in microgravity, we studied, let's say, a more pure phototropic response. And what we found was we actually discovered a new one in flowering plants, and that is flowering plants will grow toward red light. On Earth, that phototropic response is mediated by blue light photoreceptors. And we also have that in microgravity, but we have this additional red light response that we can't see on Earth.
I'm assuming that water plays a huge part in what's going to happen with growing plants outside of Earth's atmosphere. And we've obviously seen a lot of countries going for that coveted area of the southern pole of the moon. How much of that is going to affect your research in growing plants in microgravity or low gravity environments?
Well, it doesn't affect my research directly because we always provide the water. But you're absolutely right. I think it's different on Moon and Mars, but if you have plants, you're going to need water, and you need water for all sorts of things. So it appears like there's quite a bit of frozen water near the south pole of the moon. So that's why everyone is going there. Now, Mars is a different story. There is some evidence of water and some craters there also with water, but we know less about it. So that's going to be important for future missions, because otherwise you have to bring all the water with you, which
would be a huge weight.
Yeah, well, it's feasible for a shorter mission, longer term missions or colonies. You got to deal with the water issue somehow.
So you mentioned earlier, and I'm going to go back to it, that you've worked a lot with NASA. In fact, there is, I believe, an asteroid named after you.
Yeah.
Can you tell us that story, how that came about?
Yeah, it sounds really science fiction. The asteroid kiss. I kind of like that. So I received an award with my colleague who I mentioned, Javier Medina from Spain, from COSPAR, which is the International Committee on Space Research. And the medal is for promoting international cooperation in space research. It was Javier and I, so we had the US and Spain, but we also had people from France, Germany, Netherlands, Norway. So I was really honored to receive the medal. But along with the medal, the International Astronomical Union names an asteroid in honor of the scientist. So I got our astronomy department actually got some photos of it for me, because you really need a pretty strong, powerful telescope to see it. But it was a real honor. At first, we thought it was going to be asteroid either Kiss Medina or Medina Kiss, and we'd have to have a big fight. But they gave us both an asteroid. They were very kind.
That is quite the honor. And what a crazy thing to be able to say. There's an asteroid flying around out there that's named after me. So what's coming up for you? What are you working on at the moment in terms of your research?
Well, I'm working on a couple of projects. They all seem to be related to the moon. I've been working with a team of scientists and engineers at NASA and some other private entities to develop a small lunar greenhouse. Maybe greenhouse is a misnomer, but I've grown plants in the International Space Station. I'd like to grow them on the moon. The big issue with growing plants on Moon and Mars, I mean, there are a lot of issues. We've alluded to some, gravity, water, but it's radiation. And the radiation environment on the surface of the moon is pretty severe. There are these high energy particles. Mars is the same thing. So we don't really have a great understanding of some of these radiation effects on plants. We have even on humans. And I think that's, one of the questions for going to other planets, Moon, Mars. A lot of people talk about the spacecraft, and that's an issue. Particularly, let's talk about Mars. So you need a big rocket ship. And Elon Musk, whose SpaceX company we've used, I admired, he says, yeah, we could go to Mars. And they focus on the big rocket, which is no small engineering feat. But the real problems deal with biology, because if you go to Mars and, the humans are like jellyfish because of all the radiation also in deep space, and they just can't function on there, it's going to be a problem. And for plants, there's an immediate problem, but if we're talking about multi-generations of plants, for crop plants, producing seeds and having another generation, understanding the radiation effects are critical. And in the experiments that we're proposing, they're relatively simple in that we want to study also the effect of the combination of radiation and low gravity. Does that have an effect? So that's kind of what I'm working on now.
We'll be right back. Welcome back. As part of the Trailblazer program within the Moon to Mars initiative, the Australian Space Agency is partnering with NASA and Australian commercial space organizations to land their own rover on the moon. The goal is for this to happen as early as 2026 as part of a future Artemis mission. And once the lander's on lunar ground, it'll collect regolith in the hopes of one day helping extract oxygen from it in aid of human settlement on the moon one day. And with any major mission like this, there are a lot of important steps and considerations. Funding, building, testing, and of course, the most important one of all, naming. What to name the Australian moon rover? From now through October 20th of this year, Australian residents can enter their recommendation to the Australian Space Agency. Schools are especially encouraged to get involved and submit a name for the rover, and we'll include a link in the show notes if you'd like to send in your idea. From November 20th to December 1st, the public gets to vote on the shortlisted picks, and the winner will be announced on December 6th. Exciting, huh? As for name suggestions, well, ISRO named their lunar rover Pragyan, which means wisdom in Sanskrit. China's rover was called the U2, which means jade rabbit. Some very interesting ideas there, naming a rover after an idea or a mythical creature. Other rover names have been very pragmatic, like the US's LRV or Lunar Roving Vehicle. I think Australia can do better than that. If you're stuck and need an idea, Australia, our executive producer Brandon Karpf has a solid suggestion. How about Rover McRoverface? That's it for T- for September 5th, 2023. For additional resources from today's report, check out our show notes at space.n2k.com. We're privileged that N2K and podcasts like T- are part of the daily routine of many of the most influential leaders and operators in the public and private sector, from the Fortune 500 to many of the world's preeminent intelligence and law enforcement agencies. This episode was produced by Alice Carruth. Mixing by Elliot Peltzman and Trey Hester, with original music and sound design by Elliot Peltzman. Our executive producer is Brandon Karpf. Our chief intelligence officer is Eric Tillman. And I'm Maria Varmazes. Thanks for listening. We'll see you tomorrow.